Hello everyone, welcome back to MAC1140. So let's continue with section 8.3. In this section, we'll be learning how to solve system of nonlinear. Maybe some of you already been familiar with the system of nonlinear equation. Nonlinear, it means there's something that is not linear. And the first time we learned how to solve system of nonlinear equation when we are in college algebra. Remember, that is one of the sections we have to cover in college algebra. But the difference between the nonlinear system in pre-calculus and the nonlinear system in college algebra is that in nonlinear system of in college algebra, one of the equation is still linear. So one of the other equation is nonlinear, but the second equation is still linear. However, in pre-calculus, both the equation will be nonlinear. Just think about it. When we have a conic curve, right? And all the conic curve is nonlinear equation. Okay, and if we draw two conic curve overlap each other, so it means that these two conic curve will intersect each other at most 4 points. Okay, we find it in the intersection point. Okay, between two conic curve is nothing but finding the solution for the system of nonlinear equation. Okay, so let's get started today. All right, so section 8.3. Okay, system of nonlinear equation. Well, there's so many nonlinear equation, you know. Conic equation is just one of the example. Okay. So how are we gonna solve this? How are we gonna find intersection point between two nonlinear curves? How we do that? Traditionally, when we learn some of the system in college algebra, we learn how to use elimination method and substitution method, right? So for nonlinear equation system is the same thing. We can use substitution, or we can use elimination, but most of the times we use substitution. Sometimes we have to use both methods. In pre-calculus, I might introduce you another method. Remember when we learned how to use naming variable method? We name another variable to replace for one of the variable in equation and make the equation or the system simpler. You remember that method I already showed you last time? I think one of the first few weeks of the semester. I remember I showed you that. Okay, so we learn how to use naming variable method to solve the system of nonlinear equation. If I have time, I'm gonna show you how to do that. Okay, but if not, then we just stick to very traditional way, the substitution and elimination method. Okay, so let's start with our first example. Okay, let me see example 1. Yeah. So let's do this example. So I have a system something like this. So I have x squared plus 3xy, okay, plus y squared equal 22. And the second equation I have is x squared minus xy plus y squared equals 6. So we try to solve this. So you see that both of the equation here are non-linear. So basically the highest exponent is the second degree, so it's not linear. Okay, so it's different from the one we already learned in college algebra. So how we're gonna do this? Let's try to use the traditional method, okay, substitutional elimination method to do this. Alright. So if you can recognize that the first equation that contains x squared and y squared, the second equation also contains x squared and y squared. So if I subtract the second equation from the first equation, so I subtract 2 from 1, then it means that I take this minus this. So what I have, so minus, so I will have this minus cancel out, right? So this is y squared minus y squared cancel out. 3xy minus xy, so it gives you 4xy, right? Equal to 22 minus 6 give you 16, I believe so. Yes. So from here I can make the equation simpler, so I can get xy equal 4, right? Okay, so if xy equal 4, then I can get y equal 4 over x, right? 4 over x. Alright. So if y equal to 4 over x, you see that I can use substitution method. I'm gonna just go ahead plug this into the second equation. So okay, so I'm gonna plug this. Okay, plug star into 2. Then what we have? We will have x squared minus x, right? Times 4 over x, right? Plus, right? Y squared will be 4 over x totally square, right? Equals 6. Is that true? Is that correct? Yes, right? Hopefully I don't have any careless mistake. So from here I will see that I can cancel this out. So I will have x squared minus 4 plus 16 over x squared equals 6, right? Okay. Then from here, what we have from here, I'm gonna multiply both sides by x squared because I find LCD, so I'm gonna have. Well, let me cancel. Let me simplify this. So let me simplify this first. So I will have x squared minus 10. I subtract both sides by 6. Okay, equal plus 16 over x squared equal 0, right? Right. Then I will multiply both sides by x squared, so I will have x to the 4 minus 10x squared plus 16 equals 0, right? Right. So from here, I can you can factor or you can name variable if you want to. So from here I can factor them because this one is very familiar equation. We already learned how to solve it. So you can factor or you name variable. So you can factor like this. So this becomes x to the 4. So you have x squared and x squared, right? And 16 will be, and you want to be negative 10 in the middle. So it must be negative 8 and negative 2, right? Equals 0, right? So from here you can split it above. So x squared minus 8 equals 0, right? Or x squared minus 2 equals 0. Then you will have x squared equal 8. Then x will be equal to plus minus square root of 8. Over here x squared equal 2. Then x will be plus minus square root of 2. Okay. So you see that we have totally 4x. And I'm gonna plug them back into the star. Okay. So I'm gonna plug them back into the star equation. So this is the star equation right here. The star equation right here. So this is the star equation. Okay. So I'm gonna just circumference. So this is the star equation to find y. Okay, so right here we have plus and minus. I'm going to plug it in. So we have y equal to 4 over square root of 8. Okay, and y equal to 4 over negative square root of 8. Okay, similarly over here I will have y equal to 4 over square root of 2 and y equal to 4 over negative square root of 2. So totally I will have 4 intersection points. The first one will be square root of 8, 4 over square root of 8. If you want to simplify, go ahead, but you don't have to. The second one will be, the second intersection point will be negative square root of 8, comma negative 4 over square root of 8. The third one will be what? Will be square root of 2, comma 4 over square root of 2, and the last one will be square root of 2, negative square root of 2 over comma negative 4 over square root of 2. So you see that you have 4 intersection points. It means we have 4 solutions. Okay, we have totally 4 solutions at most. Well, just think about it. You have a circle, right? If you think about a conic curve, you have a circle and you have an ellipse, and you let the circle overlap the ellipse, and you will see that it has 4 intersection points. Okay, but that is when I'm talking about the conic curve. You know, there's a lot of nonlinear system of equation that contain more than 4 intersection points. Okay, so it can contain more than 4 solutions. All right. So that is how you solve the system of nonlinear. So basically kind of the same as we solve any system. Okay, so let's do another example. How about this? Let's see. How about I have so let's do something simpler. Then on the third example, I'm gonna do the hard one. Let's do the hard and the easy, and the hard and the easy. Let's do this one. Let me see. I can pick up something all the way down here. Let's see that we can do that or not. Well, they don't have a lot of many problem here. So I'm gonna just go ahead and pick one of them. So example 2. So I have the system like this. So this one may be easier than the last one. So I have x squared plus y squared equal 4. You see that this is a circle. You see that right away, right? And I have 5x squared plus 5y squared equal to 28. So look like this one is what? This one is look like what they look like? Anyone can recognize it? It look like what? What do it look like? Either ellipse or hyperbola, right? So this look like this is an ellipse because it look like there's an addition right here, right? It's an ellipse, right? Yeah, but I mean, if you divide both sides by 5, but it still doesn't work. So I mean, you should divide both sides by 28 so that you have 1 over here. Then you have an ellipse, right? And because the hyperbola, it should be the minus. So this is the ellipse in the circle. So you should have 4 solutions in this problem. So this problem is kind of very easy too. You can use substitution method easily. So from here you see that you can get from the first equation here you can get y squared equal to 4 minus x squared, right? So easy. This problem is very easy. Then you're gonna plug into the second one. Then you have 5x squared plus 5 4 minus x squared equal 28, right? Oh my god, this is so easy. Okay, then what I have, I'm going to distribute, so we have 5x squared plus 20 minus 5x squared. Ooh, interesting. So y squared, okay, equal 28, right? All right. And look like I can show out, and then I have 20 equal to 28. Look at that. How come 20 equal to 28? So this is, it does not make sense, right? This is like, it doesn't make sense at all. It's not logical. Okay, so this is not logical. So if you have something that is the wrong statement, okay, so then that is wrong, then you can jump into conclusion. This is no solution. What does it mean when you say no solution? You see, it means that these two curves over here, it never intersect each other. It never overlap each other. Okay, so that's the second example. Okay, let me see. We can do another one. Let me check here. Okay, how about this one? Let's see. Okay, example. I think I'm gonna jump to the next page because yeah, because we on our page already. So let's jump to the next page. Okay. How about this? So example 3, right? Example 3. Okay. Let's do this. Okay. I have the system like this. I have x plus y plus xy equal 11, and the other one is x squared y plus y squared x equal 30. Okay. So you can use substitution and elimination method for this too. However, just think about it. This is, you cannot add or subtract these two equations together to simplify that, because it is xy and xy squared. There's no way you can do it. And you might use substitution, but it's very difficult. Just think about it. You're gonna factor the y over here, and you're gonna subtract both sides by x, and you divide everything by 1 plus x. Then you're gonna plug that y in here, and just think about it, this is square. So this is very hard if you do substitution too. Okay, so if substitution doesn't work and elimination doesn't work, then we have to consider the naming variable method. Naming new variable method, it will make your system simpler. Okay, but what we're gonna name? What we're gonna name? And we name what? Okay. Okay, so before I name a new variable, I'm going to do one more step. Okay, so over here you see that x and y in common, so I'm going to factor x, y out, so you have x plus y equal 30. So what do you see over here? So you see that, let me use this color right here. Okay, so you see that over here we have x plus y. Okay, and the second equation we also have x plus y. On the top equation we have x times y, and the bottom is also have x times y. Look at that. Look at that. This is look like it follow the pattern, right? So in order to solve this, I'm gonna name variables. So I'm gonna call. Okay, I'm gonna call, because x plus y is a sum. So I'm gonna use s variable. So I call s equal x plus y. Then the x times y is product, right? So I call p as product is x y. So after I name variable, my system become what? So my system will become my system will be what? Will be sy become s, right? Plus p equal 11, and the bottom over here become what? Become p times s plus y is p times s equal 30. And now what we have over here? So originally we have the second degree over here, and even though that we don't have a second degree, but it's very hard to do, how to solve. But we simplify that the whole system. Now the system is very simple. So what you have to do right now is just use substitution methods, the very traditional substitution method you already learned in college algebra. So I'm going to solve S and P. Okay, so from here, so I'm going to call this the first equation, this is the second equation. So from the first equation, okay, from first equation here, I can get S equal to 11 minus P, right? Then my second equation, I'm going to substitute the S into this one. Then my second equation will become P times, so I replace the S with the 11 minus P equal 30, right? Right, so from here I will multiply them in, so I will have what? I have 11p minus p squared equal 30, right? Then I'm gonna just reorder them, so I have p squared minus 11p plus 30 equals 0, right? And what we have here, what equation we have here? We have quadratic, right? So I can factor this out, so I can factor that, right? So this will be p here and p here, and 30. So in order to get negative 11, you can do negative 6 and negative 5, right? Equals 0. Okay. Then from here you can set each of them equals 0, or p minus 5 equals 0, and you can get p equals 6 and p equals 5. And if p equals 6, then you're gonna plug back, okay, plug it back into I'm gonna call this equation is the star equation. So I'm gonna plug p into star equation. Okay, so after you plug p over here, then what s becomes? So if p equals 6, then s become 11 minus 6, right, equal 5, right? And over here the new s, if you plug p equal 5 over here, so 11 minus 5 over here, so it become 6. So you have s is 5, and if s is 5, p is 6. If s is 6, p is 5. Okay, now alright, if s is 5, p is 6. Okay, let me write over here. If s is 5, oh, you don't have to write it. If s is 5, p is 6, then you're going to plug them back because our goal is to get x and y. So if s is 5, p is 6. So our system right here. So let me call this is the system. Okay, so I call this system a system. So this is system. Let me name it system. This is star. So this is system 2 star. Okay, so I'm gonna plug s and p into systems 2 star. Okay, so plug s and p into a system 2 star. Then what we have? So if s is 5, p is 6, right? So if s is 5, p is 6. So s is 5, s is 5. Okay, p is 6. There you go. All right. And if s is 6, p is 5. If s is 6, p is 5. Here you go. So I have another two system. I have another two system to solve for x and y. So from here I can solve y in terms of x. So from here I can, so I'm going to split up into two systems. This is actually, there's two systems. Okay, so I'm going to serve this system first. Okay, I'm going to serve this one first. So I'm going to serve system A first. So I'm going to call this system over here. I'm going to call system A, and over here I call system B. Okay, so I'm going to serve system A. Okay, let's serve system A first. So alright, so system A first. So now system A is very easy to solve. You can use substitution method, right? So you can get y equal to phi minus x, right? Then you're gonna plug y into here, so you will have 6 equal x times phi minus x. Then you will have let me do it over here so that we can save some space. So my equation becomes 6 phi x minus x squared, right? So I can reorder them. So I can have x squared minus phi x plus 6 equals 0. And now you can factor them out. Alright, so you have x minus 2, x minus 3 equals 0. Then you can use zero product property. You solve, so x 2 equals 0 or x minus 3 equals 0. Then you have x equal 2, x equal 3. And if x equal 2, you plug them back here. So if x equal 2, then y equal, you plug it back in here. Okay, y equal 3. If x equal 3, then y equal 2. Here you go. Then you will have 2 points. You have 2 points. Now we're gonna solve system B. Okay, we're gonna solve system B. Now solve system B. So this is system B. So this is system B right here. So this is system B right here. All right. So I'm gonna solve. I'm gonna use substitution method too. So I'm gonna solve y in terms of x, so it's y equals 6 minus x, right? Then I'm gonna plug into the second equation. So you have phi equal to x times 6 minus x. Okay. So you have what? You will have so this x. So we have phi equal 6x minus x squared. If you reorder them, so you have x squared minus 6x plus phi equals 0. And you can factor. So you have x minus 1, x minus phi. Everybody know how to factor already. So I'm gonna kind of do it really fast over there. X minus 1 equals 0. You use your zero product property equals 0. Then you have x equal 1 and x equal phi. And if x equal 1, you plug them back in here to get y. So you will have y equal, plug in here, okay? Plug in here. So y equal phi. And if x equal phi, then y equal what? Y equal 1, right? There you go. Then totally, how many points we have? We have, we will have, okay, let me see. So we're gonna have 1 point, right? This 1 point right here, 1 intersection, 1 solution, 2 solution, okay, 3 solution, and the last one is 4 solution. There you go. So totally we have 4 solutions. So that makes really sense. Okay, make really sense because that's a system of it's a ellipse and no, this is not an ellipse. It's just a nonlinear equation. So we cannot define if it is ellipse or not. Let me check one more time. What is that? Yeah, we cannot tell. But this is the nonlinear one. It's nonlinear one. So that is how you use naming variable method to solve for the system. Okay. So you can stick to the old way, but I mean it's very hard to solve with the old way. So I'm going to use another way to solve it. So maybe on the test I won't give you this, but on the assignment I might give you this. Okay, I might give you something like this. So make sure you know how to use naming new variable method to solve system of nonlinear equation. Okay. So I'm gonna stop our lecture over here. But this is a kind of very short lecture because it's nothing. I mean, it's not a new concept. It just this section it just require you to do more practice. Okay? As long as you do more practice, then you get used to it. Okay. Alright, so next time we will be talking about section 8.4. 8.4 is the last section of chapter 8. Okay, please let me know if you have any questions relating to example here. You can send me the message in Canvas. Don't email me because if you email me, it's your email. I receive 100 email per day, so I mean your email will be falling behind. So just send me the message to Canvas, and I'll try to reply to your message as soon as I can. I'll see you next time. Bye bye.